Hi, Halo Effect here. In my travels of learning how to solve a Rubik's Cube, this is a cube where I've actually done the top layer already, and I'm working on the second layer. I sort of accidentally discovered this really cool, potentially helpful little algorithm. Now, normally when you're doing a second layer like this, and you want to insert one of these top pieces into this middle layer, you'd use the algorithm I'm about to show you. It's one of the standard basic techniques to do this. So this obviously is a center piece, or sorry, an edge piece. That's blue and orange, so it should go between this blue and this orange. So that piece should really end up here, and you can see it would fit. The usual way of doing this, of course, and everyone knows this now, is what I call the away, up, back, down, towards, up. If it works, back and down technique, and now it's where it belongs. Sometimes you'll find this unique position like this, whereby these two are actually both need to be kicked up, moved to the correct position, and then put back where they belong. This piece actually belongs here, but it's oriented incorrectly. This piece belongs here because it's red and green, so it goes between the red and the green, but it's oriented wrong as well. Now, my usual method for doing this, and the same for you if you're using standard basic method, is simply to do that same move you just saw, that I just showed you, once to kick this up to the top, doing that algorithm again to bring it back down into the correct position, then doing that algorithm again to kick this piece up to the top, move it where it goes, and use it one more time to put it back into place. So in fact, you'd be using that algorithm 4 times. But this is an instance where it would be very helpful to just be able to kick both of those two pieces, those two edge pieces, up into the top in one algorithm. F2 in either direction because it's a 2, and then U2 again in either direction. Turn this once, the front once, in either direction technically, but I always go clockwise, and then reverse that previous part. So U2 again and F2 again. And you can see what that's done is take those two pieces that were here and here and kick them both out onto the top layer. So one of them is here and one of them is here. And if you do it exactly that way, these two will always be kicked up into those two exact same positions. From those two here, one here, to these two here, one here and one here. Now it's a fairly easy process of taking the one that's already sitting here, the green-red, putting it over top, and from there using those same algorithms. So that's a handy way of using this. Something else I noticed, and again this took a little more practice and a little more messing around with it to make it work, is that if I reuse this again, so front to U2, and rotate this back into place, around and around. Now, let's say we had these two and they were oriented correctly. In other words, the red of this piece was here, and the red of this edge was here. Well, now they're actually in the correct place, and all you really need to do is swap those two. And you can do that with this I'm about to show you, so that green-red is going to end up over on this side, and this green-red will end up over on this side. And actually what I'm going to do is go off, swap these around so that the reds are correct, and I'll show you exactly how this works in just a moment. Be right back. So that was how to push two edge pieces up to the top in one fell swoop. This is a slightly different use of pretty much the same algorithm. So this is a different setup where you can see that these two are basically in the correct orientation, but in the exact wrong positions. These are swapped. So this is a green-red piece that should be over here with this green, And this is the blue-red piece that should be over here with the blue. Now, again, normally you would have to use that original algorithm once to pop this up, again to bring it back down where it fits, a third time to pop it up to the top, and one more time to bring it back down to where it fits. Well, in fact, that up to here, down to here, and then this up to here, down to here. What I'm getting at is, again, you would have to use that original algorithm, that simple algorithm, 4 times. But here's one algorithm that does it in one fell swoop. And here it is. It's just a minor variation of the other one. So, again, this is green where it should be blue, and blue where it should be green. So just start the same way, up and around, like that. But this time, instead of turning this front just once, we're going to turn it twice. And then just bring it back around again. 1, 2, and bam, just like that, the bottom is still correct. And now, these two have been swapped, all in one move. Hope that's helpful to you guys. It's helpful to you as I found it myself. I certainly have run across both of those on occasion. Now in future videos, what I'd like to show you, if I'm able to, is how I took this really crappy dollar store, and I do mean dollar store. This is a $1.25 Rubik's Cube. This is one of the ones I didn't use. I'm sorry, not a Rubik's Cube, it's a 3D puzzle. Let's call it what it is. How I first tried to change that into this is more or less the same, but as you can see, I've done some minor alterations on the center, but this is still pretty rough. Can't really get it past there without really torquing it or going the other way. This is certainly not a speed cube. This isn't even really a very good Rubik's Cube. It gets caught an awful lot. What I'd like to do next video is show you why by taking it apart, and also what I did with this one to make it basically, well, not only look a whole lot better, not have those stupid edges that were sticky there, but also basically this is now a speed cube. And believe it or not, this is just the end result of an awful lot of work that I'm going to show you. And you can see one of the issues I have is that, well, I'll get into that in the other video, but look forward to that. Cheers. Enjoy cubing. See you soon.